Alright, so next we have to look at integral of the form a to the x, a x to the n. We need to look at integral of the form a x to the n. Now, if we integrate x to the n, what we're going to get with respect to x, what we're going to get is x raised to the power n plus 1 divided by n plus 1 plus c, where of course n is not equal to 1. So what we're seeing is that when we integrate x to the n, what we have to do is we have to increase the power n by 1. So the new power becomes n plus 1. And we divide by the new power plus c, which is the constant of integration. All right, let's have a look at some examples. Example 1. In example 1, we're asked to find the integral of x to the fourth. Now, if we're going to integrate of a function of the form x to the n, what we must do is that we must raise the power by 1, divide by the new power, and then add c. So therefore, the integral of x to the fourth dx is equal to x to the fifth power. So we increase the power by 1, divide by the new power 5, plus c, which is the constant of integration. All right, let's have a look at another example. Example 2, similar idea. We're asked to find the integral of x to the 7 dx. So we're again integrating a function of the form x to the n. And in such a case, we must increase the power by 1, so the power becomes 8, divide by the new power, and then add c, which is the constant of integration. Example 3, which is of a similar form. All right, so first of all, this is the same as saying the integral of x raised to the half power. So square root is the same as saying the power is a half. Now, this is again integrating a function of the form x to the n, where n is the power. And what we have to do is that we have to increase the power by 1, then divide by the new power and add c. Now, here the power is a half. If we increase the power half by 1, it becomes 1.5, which is 3 over 2. So this is x to the 3 over 2. Divide by the new power, which is 3 over 2, plus c, which is the constant of integration. Now, dividing by 3 over 2 is the same as saying multiplying by 2 over 3. So when you divide by a fraction, you change the division sign to multiplication and invert the fraction. So it's multiplying by 2 over 3. So this is x to the 3 over 2, which is the new power, plus c, which is the constant of integration. All right, one more of that form. So the integral of 1 over x cubed with respect to x is the same as saying the integral of x raised to the minus 3 power, all right, dx. All right, so here we're just simply applying our law of indices, which says that if you have, let's say, a to the minus n, this is equal to 1 over a to the n. That's the law of indices. So this is sort of like a reverse application of that law. All right. So if the power is at the bottom, if you want to bring it up, you have to change the power to negative. So now we need to increase the power by 1. When you add 1 to minus 3, you get minus 2. So this becomes x to the minus 2 we have to divide by the new power, which is minus 2, and then add c, which is the constant of integration. So the answer here becomes minus 1 half, minus 1, let us remove that, minus 1 over 2x squared plus c. So again, here we're just applying the law of indices. If power is negative and you want it positive, you have to bring it down into the denominator. And then we add c, which is the constant of integration. All right, integration theory. Theorem 1 says, since when we differentiate c, we get 0, where c is a constant. If we integrate 0, we are going to get c, which is a constant. So if you integrate 0, you're going to get c, which is a constant. Theorem 2 says, if you differentiate x plus c, you're going to get 1. Therefore, if we integrate 1, we're going to get x plus c. And of course, because integration is reversing differentiation. Integration is reversing differentiation. Theorem 3, which says if we differentiate a to the x plus c, we're going to get a. So if you differentiate ax, you're going to get a, and if you differentiate c, which is a constant, you're going to get 0. So if you differentiate ax plus c, you're going to get a. So if we integrate a, which is a constant with respect to x, we're going to get ax plus c. And again, because integration is reversing differentiation. Theorem 4 says the integral of a of f of x dx with respect to x is equal to a, the integral of f of x dx. All right, so in other words, the a, if you're multiplying a function by a constant, that is equal to the constant multiplied by the integral of the function. All right, theorem 5 says that if you're integrating the sum of two functions with respect to x, then it's going to be the answer is equal to the integral, the sum of the integral of the two functions separated of the it's equal to the sum of the integral of the two functions. Theorem 6 is similar to theorem 5. If you're integrating f of x minus g of x, that is what? The difference of two functions with respect to x, it's equal to the difference of the integral of the two functions separated. Again, with respect to x. All right, example 5. So let's just have a little application, so to speak, of the theorems. In example 5, we're asked to find the integral of 4 with respect to x. All right, so here, if we integrate, if we're going to differentiate, if we differentiate 4x plus c, we're going to get 4. So if we integrate 4, we're going to get 4x plus c. So if you integrate a, you're going to get ax plus c, where a is a constant. So if we integrate 4, if we integrate 4 with respect to x, we're going to get 4x plus c. Example 6, we're integrating 7 times some function f of x. So we could say that the integral of 7 x squared dx would be equal to 7 times the integral of x squared with respect to x. So here we're multiplying the function x squared by 7. So the integral of 7x squared is 7 times the integral of x squared with respect to x. So this is 7. When we integrate x squared, we increase the power by 1. This becomes 3. Then we divide by the new power 3. And we add c, which is the constant of integration. Alright, so if we want, we could write it as 7 over 3 x cubed plus c, which is the same thing. Alright, example 7. So here we are asked to find the integral of the sum of two functions in x. So this, therefore, the integral of f of x with respect to x is equal to the integral of 3x to the fifth power plus 2x to the minus 2. And of course, we're integrating this with respect to x. All right. So this is going to become 3 times the integral of x to the fifth with respect to x plus 2 times the integral of x to the minus 2 with respect to x. So here we're just applying our integral theorems. Now it's a power integration, so we're going to increase the power by 1 and divide by the new power. So we have 3x to the 6th power divided by 6 plus 2x to the minus 1 divide by minus 1 plus c, which is the constant of integration. So this is going to become, well, this goes into this 2 times, 1/2 x to the 6th minus 2 over x plus c. All right, so we're just applying, well, a positive divided by a negative is a negative, and applying our law of indices, which says a to the minus n is equal to 1 over a to the n. Applying that there, so x to the minus 1 is the same as saying 1 over x. All right, and the last example before we end this video. So this becomes the integral of 3 the integral of x to the half power minus 8 the integral of x to the third power. All right, and this is with respect to x, and this is with respect to x. So this becomes 3x to the 3 over 2. We increase the power by 1, then divide by the new power, which is 3 over 2 minus 8x to the 4, divide by the new power 4 plus c, which is the constant of integration. So now dividing by 3 over 2 is the same as saying multiplying by 2 over 3. So this is 2 over 3 multiplied by 3x to the 3 over 2 minus 2x to the 4 plus c. 3 cancels 3. We end up with 2x to the 3 over 2 minus 2x to the 4 plus c, which is the constant of integration. All right, and that is the end of integration of the form x to the n. Plus, we had a look at the theorems of integration, or the integration theorems.